CLI and a cross-platform IDE for C and C++. Download now.
Okay, so let's get started. This session is a talk about MISRA C++ 2023 and what is going to come next. I'm going to quickly present myself. So I'm Loïc Joly. I work at a company which is called Sonar. You have the link here. And this company is providing static analyzer tools for many languages, and among them C++, and that's where I'm working. And the main product of this company is called Sonar Cube. It's very well known for many programming languages. Maybe not the leader yet for C++, but it's a very good product. You should try it if you have time. And apart from that, I'm also a member of the ISO C++ committee as a part of the French national body, which means that you came to this session are going to hear lots of bad English accents and with a French twist. And then I'm also a member of the MISRA C++ working group, which defined the MISRA C++ 2023 documents. So I'm here to speak about it and also to speak about what's going to come next. So first question is, what is MISRA? Well, MISRA is a set of guidelines to write sane C++ code, because you all know that C++ can be a wonderful language, but it's also a language that it's very easy to misuse. And people felt that it was useful to provide some guidelines, especially in the automotive industry, because or in any safety critical system where if you have a bug, it can mean that people are going to die. So just using C++ without any guideline, it felt a little bit too risky. So people met and defined this kind of guidelines for C++. But it's not only used for the automotive industry, it's also used for other critical systems. It's also used in places where the code is not safety critical, but it's a nice set of guidelines. So it's very well known, and many people are using it. So the latest version of MISRA C++ is MISRA C++ 23, and it targets C++ 17. I'm going to come back on this point later. And it contains 179 rules. And one of the interesting points of MISRA compared to other guidelines is that rules are defined precisely with static analyzer tool vendors in the loop. So when a rule is defined, it means that people already have an idea about to make it inside of a tool and to make sure that it's defined accurately enough so that the tool can implement it. And it's also defined in a way that there should be no ambiguity whether some code is compliant or not. So if you switch from one tool vendor to another tool vendor, you should get compatible answers about the compliance of your code. If you look at an history of MISRA, so this is a summary of it. MISRA started in 1998 with MISRA C. And there were several versions of MISRA C. The latest one was MISRA C 2023. It's C is not a language that moves a lot. So every additional version of MISRA C is like incremental versions. They're adding new rules. They're fine-tuning some stuff, but it's not a real revolution. After MISRA C 2004, some people said, yes, it's great. We can use C and embed in automotive software. But what about C++? So a group of people decided to write MISRA C for MISRA for C++, and the document was published in 2008. And between 2008 and 2023, nothing happened in MISRA. It kept that way for a long time, which meant that MISRA C++ 2008, of course, was targeting C++, not even O3 or a little bit, but mostly C++ 98. So it was not enough for people who wanted to use more than C++. So there was a group of people who designed a set of libraries for communication in the car, which was called AutoSAR. And because they could not directly use MISRA C++, they developed their own set of guidelines, but they didn't want to. They did it because they had to. So when at last the MISRA C++ decided, the group decided to meet again and to create a new set of guidelines, AutoSAR said, okay, we're going to stop AutoSAR guidelines and we're going to switch back to MISRA C++ 2023 when it's ready. In terms of inspirations, you might have heard of GSF. It's a Joint Striker Force. It's a set of guidelines for the military plane industry in the US. It's for C++, but it was heavily inspired from MISRA C 2004. And in terms of other inspirations for MISRA C++, there are the C++ core guidelines that were used heavily. And of course, there were cross-pollination between MISRA C and MISRA C++. And also there is a group in ISO that is working on language security, not safety, but lots of common points between both. And some people of the MISRA C++ group are working in this group to work on security. So I hope that this graph shows you that everything is connected, and it's not just something that came out of the blue, but it came from prior experience and from sharing ideas between different contexts, different group of guidelines. So what is in a guideline? So first, something I have not written, but I should mention is that MISRA is not free. You have to pay for it. The price is quite reasonable, but you have to pay for it. It's not an open source document. So I cannot really show you an actual MISRA rule on this screen right now. So, but I can show you what it is about, but I cannot show you the details of a rule. So a rule is made up first of the headline, the description of the rule. If the deadline is not enough, and in many cases it's not enough, there is what is called the amplification, where it describes in details what is and what is not inside of a rule, what are the corner cases, for example. And this part, if you read the MISRA document, if you are a tool vendor, of course you should read it. But if you are a user of MISRA, maybe you should skip it, or not skip it, but don't take too much attention into it, because the target of this section is for tool vendors to make sure that they all agree exactly on what is compliant and what is non-compliant. So if you read MISRA, this is not the most important part for you, probably. The rationale is more important. It's more user-friendly. It explains why this rule was decided. And of course, there are some examples that allows you to see what we meant. And each rule has some metadata. So I said rule, but it's the generic term is guideline. So the first metadata is that we have rules and we have directives. Rules are some things that are precisely defined. So when I said that several tool vendors should agree whether the code is compliant or not, it's true for rules. Directive, we don't have many directives, but it's more like when we have something which is a little bit fuzzy, we want to say something, to share some advice, but it cannot be directly checked in a precise way in the code. So for example, we have a directive about correct usage of memory allocation. It's a tough topic, but it's not. It depends a lot about the context, and it's not easy to have a good rule about it. So we have a directive that gives some advice about how to do it. Second metadata is the category of the rule. A rule can be mandatory, required, or advisory. If it's mandatory and you want to deliver code which is MISRA compliant, you have to follow this rule. Basically, we have very few mandatory rules, and it's usually when the rule is 100% sure that if you write code this way, you have your undefined behavior in your code. Many rules are required, which means that you can deviate from the rule in some cases. I will come back on this point later. And many rules also are advisory, which means that you may deviate also, but with a lighter process. And you may also totally say that this rule does not apply at all to the kind of software I'm writing. So I just disable the rule. Some rules are single translation unit, some rules are system level. So single translation unit means that you can determine if the code is valid just by looking at the CPP file and the included headers. System means you need to have a view of your full system to be able to assess if the code is compliant or not. Which means that, for example, if what you're writing is a library, maybe system rules will not be very meaningful for you. They are only meaningful when you are writing the final product. And then a rule can be decidable or undecidable. So I don't know if you've heard about Rice's theorem. It's you probably heard about the halting problem, which was this this theorem that it's impossible for a program to determine if another program is going to stop or not. And this halting problem can be generalized, like there are many properties of a program that cannot be determined. Like, for example, it's not possible to determine in all cases if the memories that you allocated are going to be freed before the end of the program. So some rules are decidable, which means that they don't fall into this category. For example, a rule that is just about the way you write the code will be decidable. I don't know, let's say, if you, we don't have a crazy rule like that in MISRA, but if you had a rule like a variable should be written with a capital first letter, this is decidable. You can 100% detect if it's true or false. But if you have rules about emulating the execution of the program to determine if, for example, a function is always called before another one, this is not decidable. So it's interesting to know if a rule is decidable or not, because for undecidable rules, there will always be false positives and false negatives. We have, as tool vendors, we have to make some trade-offs about how we develop it and what we try to favor between false positive and false negatives. For decidable rules, it's the job is easier. So what is the target of MISRA? There are, I think, basically three targets. The first kind of people is people who have to use MISRA. Why do they have to use MISRA? For example, if you are working in the car industry and you are providing a system that is going to be embedded on the car, in many cases, the car vendor will require that the software that you provide on your system is MISRA compliant. So as part of the contract, you have to comply with MISRA. You don't have the choice. Well, in that case, you should just use MISRA. There is no question. Now, there are some cases when you work on safety critical code, but you don't have to use MISRA by contract. Still, in that case, I would advise you to use it because it's been designed for that. It can help you. Maybe you can have more freedom with deviations. Maybe you can say, okay, in that case, I don't totally agree with it. I will just ignore it. But I think that having any available tools that to help you is valuable. And then if you work on normal code, and I think that's probably the majority of you, you may not even have heard of MISRA before. But I still believe that even if you're not working on normal safety critical code, it can still be beneficial for you to use MISRA because safety critical code is code and normal code is code. And many of the problems that MISRA tries to avoid apply no matter where you're coding. The main difference between safety critical code and normal code is not a black and white difference. It's more level of grace. It's more like how much you are willing to pay to make sure that your code does not contain bugs. So some of the MISRA rules are going to be a little bit painful if you write normal code. Maybe those ones you should not follow them, but many MISRA rules apply as effectively to safety critical code and to normal code. So I would say if you work on normal code, I would still advise to use MISRA partially. Maybe some rules are not that important for you, but at least look at them and decide if they apply or not in your situation. And for that, I would say that good tool support is key. I will come back a little bit later on what I mean by good tool support, but you can try several tools and select which one you want, which one best fits your development process. And also an interesting point is MISRA is that it works today, and it has lots of history. So the rule have been refined over time. So that's also something interesting. Yeah. And as I said, you might want to deactivate some of the rules, but for most of them, I think that will still they are relevant for any kind of software. So now I'm going to show some example of some rules, but I'm not going to show them directly. I'm going to start with a little quiz. So let me find the right window. Here it is. So I'm going to start the quiz. You should see a window appearing on your side when you see 4 possible answers for this quiz. And so the question is, what is written by this program? There are 4 options. It can return 0. It can return 1. You can say that the program will not compile, or you can say that the program will compile but contains undefined behavior. So it's I will let you a few, maybe not a few minutes, but maybe 1 minute or 2 to read it, because it's not so easy to read. Say. Okay, so the results are very much spread. So let's go through this code together. So there is a template class, and it's templated by a piece type, and the get function gets a default value, which is so we get a piece on the board, and it's templated to say what is the kind of piece which is as sentinel for empty piece, and right now nothing is implemented, so it always returns empty. And here we are creating a board. So it's the chessboard inherits from board, and it is empty with 2 coordinates. It used get function with a make pair, and it will test if it's equal to the default value of the type. So the trick is, so it compiles. That's the first point. It does not contain undefined behavior, or at least I don't think it does. And the tricky part here is that when you look at that, you say, okay, you are calling the get function of the base class. It always returns empty. Empty is defined as the default value for int in that case. So yes, 0 is equals to 0, so it should return 1. But in fact, the trick is that it's not going to call this function at all. This base class is a template. And we used our own template argument to instantiate the base class. So it's called a dependent base class. And when we are looking at a non-qualified name like get, we are not allowed to look into dependent base classes. What we are looking at global functions. Well, if there was a get in the same class as chessboard, it would be selected, but there is no get in chessboard. So we look in the available namespaces. And there is a get function in the utility header. And if you pass a pair to this get function, if you call get 0 of a pair, it will return the first member of the pair. If you call get 1 of the pair, it will return the second member of the pair. So this is the function that is selected when you're calling this. So it will return the first member of the pair, which is 5, and 5 is different from 0. So the answer is false. So it's I think it's a nice, tricky code. And the interesting part is that it matches one of the MISRA rules. Otherwise, I would not have said it. So there is a rule in MISRA that says that when you see a name that is resolved through unqualified lookup, it should not match a name in a dependent base class. So this code is non-compliant with MISRA because there is this get name, it's not qualified, and there is an equivalent name that people might believe would be the selected one in a dependent base class, but it's not going to be selected. So that's one of the the main focus on security in MISRA, which is the code has to be obvious to be able to one big part of safety critical is that people should read the code and understand what the code is doing. In that case, when they read the code, they might believe that it's calling the function of the base class. It's not doing that. So it's not considered as safe. So that's a violation of MISRA. So this was the first quiz. Let's go to the second one. The code is smaller, and I'm going to open to launch the second quiz. So this time the question is what is displayed if it compiles. And here I'm assuming that you are working on a typical desktop environment with typical sizes for ints, for example. So we also have spread results. Nobody said it won't compile. That's great because it does compile. And the main question is what is the type of this expression? And so you are subtracting unsigned ints with 16 bits. You might expect that the result is the same type, but that's not the way C++ or C works. When you have any operation, like minus, but many arithmetic operations, you go through a two-step process. The first step is integral promotion, and the second step is usual arithmetic conversion. So the first step is going to convert both arguments. So if the arguments are smaller than int, they are going to be converted to int or unsigned int. In most cases, they are going to be converted to int. And this is what happens here. This unsigned int 16 is going to be converted to int 32t. And this one also. And then the second process is usual arithmetic conversion. And this one, it's useful is if after the first step, the two arguments have different types. For example, if you add an int and a long, then both will be promoted to long. But it does not happen in that case. Only integral promotion happens. But because you are subtracting ints, you get an int result. So it's this function. It's this function that's going to be called. So here again, we have a MISRA rule that tries to detect that, especially because of embedded software, working with small types is more common than on typical software. So this kind of non-intuitive behavior can happen quite often. And the rule says that integral promotion and the usual arithmetic conversion should not change the sideness or the type category of an operand. In that situation, in that case, you are changing the signess of both operands because you are changing them from unsigned int to int. And this rule is a rule that might be a little bit too verbose in many code bases, but we'll see later that we have ways around it. So let's go to the last quiz. I'm going to launch it, and I'm going to display it in Godbolt. So this time the code compiles, so there is not, you don't no longer have the option it won't compile. So the question is, what is the output? It could be 2, 2, 2 other, or other 2. So this time many people have the right answer. And I'm surprised because honestly, before I looked into it, I would have had the wrong answer. So what happens here is the main question is, what is the type of this constant? And the rule to determine the type of a constant, so it's an unsigned constant, and the type of the constant is the smallest of the unsigned types that can fit the constant. So here it's going to be unsigned char probably, and the second constant is going to be unsigned int. So when you do the sum, it's going to be, both are going to be promoted to unsigned int, and you're going to wrap around, and you will get the value 2, because this one, when you wrap around, it's equivalent to -1 plus 3, plus 3, it means 2. So the first one is going to print 2. The second one is different. It's an operation which is done by the preprocessor. It's not done at runtime, or even at compile time. It's done at preprocessing time. And when you are at the preprocessor level, instead of selecting the smallest type that can fit the value, you select the biggest available type. So in this addition, I and j are going to be basically unsigned long long. And with unsigned long long, there is no wraparound needed. You can add this and you get a value that is that still fits without wraparound. So it's going to print other. So for this one, There is no direct mapping to MISRA rule because it's really a corner case, but still we have some things that could help you, which is that there is a rule that says that an unsigned arithmetic operation with constant operand should not wrap. Here, I plus j is wrapping, so you would have a violation telling you that there is wrapping occurring there, and it's probably surprising. I'm going to mention another MISRA rule, but this time it's no longer to be through a quiz. It's not longer a rule. It's a rule that was in MISRA C++ 2008. It is a rule that I believe is still in MISRA C, but it's a rule that we have removed from MISRA C++. And if there are some people who used to work with MISRA C++ 2008, I hope they're going to be very happy for the removal of this rule. It was about a rule about single entry, single exit. Basically, MISRA C++ 2008 used to say you should have only one return statement in any function. And this rule was awful. It meant that in order to write code with early exits, you had instead to add some Boolean to say, oh, am I already done? And if I'm already done, I'm going to skip the rest of the function instead of just saying, okay, for example, when you search for value, you find it, you return. You don't need to have complex logic. You don't need to introduce additional state. You just return when you need to do it. And I'm not going to go into the details because I don't have time, but to be able to say, let's forget this rule, it was a long process because this rule is referenced in IEC document that is mandated for many embedded software. So we had to find very strong arguments to say, okay, in fact, this rule is not what you believe it is. And it doesn't mean, when you see it that way, you might believe that it means a function should contain only one return. That's not what it means. It means that when you exit a function, you should go back to a unique point, which is the color of the function. This is what we believe was the intent of this rule when it was first said. I think it was in the 70s when software was written in different ways than it is now. So we could get rid of this single return rule. And then there are some other rules. I'm going to show a few other rules later. So now another question is, how does it compare to other stuff? And first, how does it compare to MISRA C++ 2008? The main difference, I would say, is that it really embraces modern C++. So as I already said, MISRA C++ 2008 was written in 2008. At that time, the way you wrote C++ was very different from the way you write it today. So it was updated, but more importantly, when MISRA C++ 2008 was written, the group of people who worked on it were mostly C experts. Some of them were C++ experts, but they were not a majority. And in some way, when you read MISRA C++ 2008, it feels like it was written by people who were afraid of using C++, of using the facilities of C++, and who believe that the right way to use C++ is to use it as you use, to just use the C part of it, and maybe add classes and virtual functions, but nothing more. It's of course it's an exaggeration, but some part of it feel a little bit like it. MISRA C++ 2008 was really written with several C++ experts in the room, and it embraces modern C++ because we are convinced that C++, the advanced tools provided by C++ allow you to write safer code. And there were also some parts in MISRA C++ 2008 which were not directly targeting safety concerns, but which were more stylistic, and they were removed also. So how does MISRA compares to compiler warnings? Well, compiler warnings are usually only there when the compiler is pretty sure that what you did is bad. MISRA is a little bit more strict because even if the code that you've written has a very well-defined meaning, if we consider that it's not clear, we are still going to raise an issue, like the example that I showed in the first quiz. The code in the first quiz should probably not raise any warning by any compiler because there is absolutely no ambiguity about it. There is no objectively dangerous pattern detected, I don't think any compiler is going to raise a warning for that. Still, it's code which is hard to understand. So MISRA considers that it could pose safety issues. Another point is that MISRA defines a deviation process for an issue. So some compilers have a way to disable a warning for specific violations of the warning, not across the full file. Not all compilers provide that. So usually it's very useful to be able to say, okay, in that case, I want to ignore the issue, but all other case, I want to take them into account. So it's part of MISRA that they should provide this kind of facility. Compiler warnings are not always fine-grained. And I would say that it's complementary. Use the warnings, use the compiler warnings, put them at a high level, select WO, select pedantic, everything that you want. It's not going to hurt you to have good warnings, and it's not going to hurt you to have MISRA on top of it. Now, if I compare it to C++ core guidelines, or basically to any good practices book, like the effective C++ books or anything like that, one of the main differences between MISRA and those is that MISRA is really defined with tooling in mind, which means that we start from the code. Let me give you an example. There is a rule in MISRA about what is commonly called the rule of 0, or the rule of 5, or the rule of 3, depending on the version that you're looking at, which is basically what are the special member functions that you should provide in a class. And the way it's defined in books or in C++ core guideline is more like, if you want to have a class that have these characteristics, this is how you should write it. So it starts with the developer intent, and it goes to the code. But MISRA is written the other way around. We don't know what is the developer intent. We are really focused on rules that can be detected by tools. So MISRA specifies, okay, if you have a class that contains this function, this function, this function, then it should also contain this other function. So this is a different mindset. It's and I tried to implement some rules that were there, because in my company, I'm not just doing MISRA static analysis, I'm doing any kind of static analysis. And I tried to take some inspiration from C++ guideline. Basically, when I want to make a rule based on C++ core guideline, there is a huge preparatory work about, okay, this is the guideline, I understand it, I understand the intent, but it cannot be directly applied to the source code. So from this guideline, how do we get a rule that is actually checkable by a tool? And it's a huge process. It requires a lot of work, and there are many corner cases that are not explained in C++ core guideline. MISRA is different. When I see the description of a rule in MISRA, I can directly start implementing it. The second point, which I said, is that different tools agree on all violations. Of course, tools have limitations, especially for non-decidable rules, but at least there is an agreement about what code should be compliant and what code should be non-compliant, because it's defined clearly. With C++ core guideline, where the definition is a little bit more fuzzy, some tools might disagree. So you might say, okay, what's the matter? Well, the matter is that you have some tool lock-in if you have different definition of the rules. And it means that if you want to switch from one tool to another one, it might raise violations at different places, and it's not going to be a pleasant experience. I'm not going to say that with MISRA everything will be perfect, but at least in theory, the different tools agree about what is right and what is wrong. So if you want to change from one tool to another, or if you want to use several tools simultaneously, you can do it more easily. As I already said, it defines what happens for corner cases. One point where MISRA is more limited than C++ core guideline is that it focuses on safety only, while C++ core guideline or other good practices book also focus on other topics, like, for example, performance. So once again, it's complementary. You don't have to use only one tool to get the job done. You can use many tools, use all tools possible. There have been some talks in the C++ community, in the C++ standard committee, to provide something which is called profiles. So it's not some things which exist now. It's in the last ISO C++ meetings, there was a decision to write a white paper about it, with the goal maybe to have it ready for C++26. I don't know if it's exactly going to happen or not, but in the base case, the first white paper would be published in about 1 year. So the main difference between profiles and MISRA is that MISRA already exists today. It can already be used, and it has been in place for many years, so it has already received tons of feedback. So it's field proven. One point which has benefits and problem is that MISRA does not have any runtime impact, while profiles, as planned, would add some runtime checks in some cases. For example, there would be some runtime checks for array boons, which could be bad because it could have a performance impact, and which is good because the consequences of that is that your code it allows to check some stuff that MISRA will never be able to check in a reliable way. So we have a rule in MISRA about you should respect the bounds of your array, but it's a non-decidable rule, and it's very difficult for static analyzer to do a good job out of it. What is going to be in profiles with the actual runtime check is something which is going to work all the time. So it's in some ways better, but it will have an impact of performance. Profiles also provide additional guarantees to the language. Because they're strict, because they have runtime checks, because they act at the language level and not at something that run on top of it, it can provide guarantees that if this profile is enabled, you have guarantee to have no memory safety issue. MISRA does not provide such guarantees. And MISRA is not going to be in the main compiler loop. It's a tool that you have to run on top of compiler. In some cases, it can be good, especially because it allows some checks to take a long time to run, while if it's in the main compiler loop, you want to have very efficient and very fast checks. So it allows it gives the freedom to have long checks that detect more problems. But the fact that it's not in the main compiler loop, it means that it's not, it's an opt-in. And if you don't opt into it, well, you don't benefit from it. While profile, they're probably going to be available by default in many compilers. Another point, which I already mentioned with compiler warnings, is that for MISRA, the readability of the code is in the scope of MISRA. It doesn't seem to be that much in the scope of profiles. And one point I'm pretty sure of is that when profiles are ready, if they become ready, I hope so, but when they're ready, there will probably be a new MISRA rule that says you should have this and this profile enabled. So once again, it's complementary. I don't think one exactly replaces the other. There is, of course, an overlap between profiles and MISRA, but there are also many differences. So how to use it successfully if you decide to use MISRA? I think there are two domains in terms of process and then in terms of C++. So in terms of process, the first important point about MISRA is that you should try to shift left. Let's imagine that you have a code base that is 10 years old, that was written without MISRA in mind, and then you say, oh, now it should be compliant with MISRA. You're not going to make it. It's going to be it's going to be painful. Many developers are going to resign. If you want to reduce your workforce without firing people, you can ask people to stop remote working, but you can also ask them to follow MISRA 100% on a legacy code base. It's as efficient. So the right way to use MISRA is to use it from the start. And when I say from the start, it means two things. It means that you should use it from the start of a project, because you don't want to refactor existing code, and you should use it as close as possible from the the fast-paced developer loop. So the best way to use it is in the IDE. You may not have all the complex checks in the IDE, but if you have some stuff in the IDE, it's already going to be good. And having it in the IDE is also helping to build good habits. There are some points in MISRA which can be painful if you don't know them, but once you get used to them, you just write the code that way and it's just working nicely. So it also helps for training developers. If they have some MISRA violations, they learn some stuff about their code, and next time they write better code. Another important point with MISRA is I mentioned this deviation process, and something which is important is that all MISRA rules are designed for the common case, but there are always cases where that are not the common case, that where there are some good reasons to say, oh, this rule does not really apply to me. And MISRA provides a process for exceptions. And there are even some rules where you expect to be exceptions. For example, there is a rule that restricts the use of for loops. And with the intent of promoting algorithms or range-based for loop, which are more safe to use than basic for loops, especially because you don't have the risk of missing the end of the loop. But to develop algorithms, you need these for loops probably. So you have two ways to work with this MISRA rule. This rule does not say anything about while loops. So one way to work with this rule would say, oh, I would need a for loop, but MISRA is complaining about it, so I'm going to rewrite my for loop as a while loop. My code will be less clear, but it will be MISRA compliant. Don't do that, please, don't do that. The right way to say it is, oh, I need a for loop. There is no existing algorithm that is going to do what I want to do. But maybe instead of directly writing the for loop, I'm going to put it in an algorithm. In this algorithm, I will make sure that I did it correctly. I will deviate. So usually the deviation process also requires that the code is going to be reviewed by someone with more experience, maybe, or with as much experience, but with different pair of eyes. So deviation usually requires higher scrutiny. So this for loop will go through higher scrutiny. But now that I've put it in an algorithm, I can reuse this algorithm in many places, and there will be no more MISRA violation. So of course, there will be a little bit additional cost when I use this for loop, but it's worth it because the code remains clear, it remains intentional. Another point in terms of process is the quality of the tool. So first, the quality of the rules themselves. So as I mentioned already, for undecidable rules, there is no perfect tool. There cannot be any perfect tool. It's been mathematically proven. So we are using heuristics. We are some maybe better than others. But even for decidable tools, there might be differences in the way that the tool reports, or there might be some small corner cases where tools disagree, or where tools are just made some shortcuts because it was too expensive to fully develop the MISRA rule. So you should always evaluate your tooling. And maybe you could consider using several tools. For example, if you have a tool which is very fast, but not very accurate for undecidable rules, and you have another tool which is more accurate but very slow, well, you might decide to use one in your IDE and to use the other one, but to run it maybe weekly. If it takes 1 week to run, it's not a problem. It's still going to give you information. As I said, speed matters. And also the user experience of the tool matters. If the tool is providing a nice message and highlights the relevant part of the code when it says that you violate a rule, it's going to be much, much easier to use this tool. And also, if you're in a situation when you don't have to be compliant, you might want to only use MISRA for the new code that you write. So there are some tools, I'm not saying name, but of course, you know that at least one tool that does it, where you can decide to focus on new code and make sure that when you write new code, it follows MISRA. But all code that has been written 10 years ago, well, maybe it's not the nicest code, but if it's been written 10 years ago and it's not bugged, well, it works. You may not have to change it anyway. And once again, it's only valid if you don't have to be compliant by contract. If you have to be compliant by contract, you cannot use this. But if you just use MISRA because you think it's going to help you, a good way to do it is first to focus on your new code, and slowly the code will become better. And maybe from time to time, you will want to apply some rules to the legacy code. But it's a way to use MISRA without becoming crazy when you have to work on the existing code. And also, MISRA is only about safety. And static analysis can offer more than just safety. There can be other rules for performance, security, checking license compliance, maintainability. So just because you check for MISRA, it doesn't mean you should not check for other stuff. Use as many tools as possible, even in the static analysis domain, to give you more information about your code. So I'm late, so I'm the last session of the day, so maybe if I'm a little bit late, it's not going to be such a pain, but I'm going to try to accelerate a little bit. So another point about MISRA rules is that sometimes they can be a little bit complex and you might feel a little bit lost. But my point here is that if you write a great C++, most of the time you should not care. So, for example, special member functions. I already mentioned these rules that basically matches the rule of 5 or rule of 0. But we have other rules that say what are the signature of user-provided copy and move constructors. Another rule that is about self-assignment in these functions. But basically, what many people have been saying for years is that most classes should follow the rule of 0. They should be based on components that behave correctly when they are copied or moved. And you should not write any special member function in most of your classes. The only situation when you have to write those is when you are writing very low-level classes, like you are writing a new container class. Okay, maybe you have to care about this. But most of your classes should not care about it. And if you don't write any of those functions, you will be compliant with the first rule, and the other rules are meaningless. They won't apply. We have rules about pointer arithmetics and low-level loops, basically the bone shakings and everything. But as I said, if you're using algorithms and ranges for loop, you're avoiding most of the problems with going out of bounds. So those rules become useless. We have rules about C-style array. The first one is don't use C-style array. And the other ones are, okay, if you deviate and you do use C-style array, this is what you should do it. Or maybe some C-style string, like those C-style string functions should not be used. Don't do that. You're in C++. Use vector, use strings, use std_array, use string view. MISRA was targeting C++17, so studspan was not existing at that time. But still, use studspan. It's a great replacement for an array passed as an argument to a function. Okay, so we have those rules about numbers that were the subject of 2 of the quiz. And those rules can be quite noisy if you're working with small numbers a lot, and that can happen if you are working in embedded software. But you should not work directly with the numbers. Don't use native types. You are in C++, you have a great type system. You can define your own types. You can use strong types. And strong types are very good to make sure that your code is good. And you can even go one step further. You can use unit library. And units library avoid a lots of mistakes in your code, especially when you're working on embedded code. And the values that you are working with are usually something with a physical meaning, like it's a speed, it's a length. You should use this information to avoid to avoid bugs. And also, if you're using some good unit library, they will go beyond the types. They will so there's the notion of quantity versus kind. Like, for example, a length is a quantity, but there are different kind of lengths. If you are working on the 2D graphics, there's probably height and width. Both are lengths, but you should probably not add a height or width. If you want to do it, it's not common. You should have a cast. Some units library provide this distinction. And there is also the notion of a affine space, which is the difference between a point and a vector. Even if you are talking about point and vector in space, so the dimension of them is distance, but a point is not a vector. It's meaningful to add 2 vectors. It's meaningless to add 2 points, but it's meaningful to subtract 2 points to get a vector. And if you are using this kind of information through a good unit library, your code if you write some bugs, the code will just not compile. So it will be really helpful. And if you do that, well, you no longer have any integral promotion because those types are not subjected to the same type as the basic type of the language. So you avoid those complex rules by writing better code. So this is to me a very important things to remember. Is MISRA is not about writing a dumbed down version of C++. MISRA is about writing great C++, and that's very important. So I'm going to the what's next part of the talk. And first, as a disclaimer from the philosopher Yoda, difficult to see, always in motion is the future. So it may change. But basically, right now in MISRA, we are working on 3 different tracks. One is Eratom from the C++23 versions. We discovered that some points need clarification. We got some user feedback. We got some tool vendor feedback. And we're probably going to publish some Eratoms on a regular basis. We have not yet, but we should do it. Next step is concurrency. Right now, MISRA does not have any rules about concurrency, and we're going to add them. They're almost ready, but between almost ready and ready, it can take a long time. And those rules are basically in 2 categories. One is categories of generic rule about the concepts of concurrency that would apply no matter the language. For example, there are some rules about the mutex lock order across different threads, and if you always lock the mutex in the same order in different threads, you avoid, you have guarantees that you're not going to have deadlocks between those threads. Some rules about atomics, and especially the consistencies the consistency models that comes with atomics. And basically, this is really, really expert territory. So what MISRA is going to say about it is don't, which means that a normal developer should not do it. And if you really want to do it, well, you will have to deviate. And as part of the deviation, you will have to make sure that you show the code to a real expert in this topic, because it's very tricky. There is a rule about recursive locks, and the intent is to ban them, because most of the time, if you are having recursive lock, it's that you are looking at too low granularity. And if you look at a higher level, usually you don't need recursive blocks, and recursive blocks are more difficult to reason about. So they are not good. And also, for example, a condition variable is it's something which is very tricky to use correctly. You have to use it in a loop, because there could be spurious wake-ups and this kind of stuff. So there's going to be a rule about how to correctly use a condition variable. And then there are some rules which are more specific to the way concurrency is provided through the standard library. For example, in the standard library, there is tothread and jthread. Well, not yet in 17, but we could write the equivalent of jthread in 17 if you wanted. So basically, we're going to say don't use thread, use jthread or an equivalent, because it's much easier to use it correctly. So just don't use async. It's not going to do a great stuff. So as I said, I don't know when it's going to be published, but the rules, we have a draft for all rules, so I hope it's going to be published quite soon. And then the last track, which is probably going to be lower priority than the first 2, is about C++20, because right now MISRA targets C++17, and C++20 is starting to be mature enough to be used in safety critical context. So we want to provide some guidance for that. And there are typically 4 categories. First, we are going to update existing rules. As an example, if a rule currently mentioned const expr, we should think about consteval, because it might be the same, it might be different, but we should ask ourselves a question about consteval if a rule mentioned const expr. C++20 comes with new facilities which are great, like source location instead of macros. Studspan, I already mentioned it. Operator spaceship, that if you only use this one to compare objects, you have a consistency between different kind of comparison, and it's easier to write, so it's less error prone. JSthread that I mentioned. So basically, MISRA is going to encourage the use of these facilities. Then there are some new facilities that are dangerous to use, like is constant evaluated. So MISRA is going to say, don't use that. It's too tricky to use. And as always, it means don't use it unless you deviate and you know what you do. And there is one point which is more controversial. It's that there are some facilities that are going to be great, but right now they might not be. I'm going to show them. modules, coroutine, and ranges, basically. Modules, these three modules and coroutines are stuff which are new, but they don't have a great tool support. For example, modules, many compilers don't fully support them right now, or if the compilers support them, the build chains don't support them. And embedded compilers, don't forget that embedded compilers usually lag behind mainstream compilers. So the tooling for them is not great. And as a community, I don't think we know yet how to use them correctly. What is the right granularity of a module? Should we make lots of small modules or a few big ones or something in between? We are lacking feedback on it. So it's great to use them if you're doing a software which is not safety critical, but for safety critical software, we believe it's a little bit too early to use them. Coroutine, it's the same. We have the raw facility in the language, but we are lacking libraries to use them. And even with libraries, coroutine require a way of thinking which is not the current one, the classical one. So we don't know exactly where we're going with coroutines. So for now, MISRA is going to say don't use them until we know better, basically. Ranges is a little bit the same. So in terms of support, the support of ranges is better than the support of the other two. Still, as a community, there are some unknowns. Some people reported having lots of problems with the dangling ranges. And also, to be able to give good rules about the use of ranges, we would require time because it takes time to write MISRA, and we don't want to delay support of C++20 MISRA too long. So mostly for the third reason, we're going to say, for now, we don't know enough about ranges to provide good rules, so we advise you not to use them. It might be controversial with some people, but we don't see any other way to do it. And there are also two other big features in C++20 that we consider mature enough, so we are not going to say anything about them. We might provide some rules about some of the details of those features, but basically those features are okay to use. So this concludes my presentation. I had to rush it a little bit, and I'm sorry for these disconnections. You can find me after the talk in Gather to ask me any question. And thank you for attending this presentation.